Right. Let's talk about group 18 now. So when it comes to group 18, these are the noble gases which are present.
Okay.
Helium, neon, argon, krypton, xenon, and radon. Got it?
Right.
So if you check it out of all of this, radon is the radioactive one here.
Yes, sir.
So rest of them are normal gases. Okay.
Yes, sir.
So where is the name coming from? Helium comes from the name Helios, which means sun. That means it is majorly the gas observed in sun. Clear? Neon.
Okay.
Neon in I think what is a Latin word is new. Okay, this is the new gas that was found. Clear? Argos, which means
Okay.
it is lazy gas. Got it? Clear.
Okay.
Krypton. Krypton comes with that term hidden. Okay, anything which is hidden. Clear? Xenon,
Hmm.
which means it is stranger. It's a stranger part of it. Clear?
Right.
Radon derived from radium itself, because this is one of the radioactive elements which was discovered on that time. Clear? So these are the
Okay.
names how they have been given. Clear? Done, beta.
Yes, sir.
Right. Next, we use the term inert gas. That means because it is low reactivity. Rare gases also is the word used because of its low abundance. Okay. It is called as
Yes, sir.
noble gases because it is very less and absurd in analogy to gold and platinum. Okay.
Hmm.
And check. Helium is the most abundant out of all. You know, in natural gas, it has been observed. Argon is the most abundant noble gas on Earth. Okay.
Yes, sir.
So, in fact, because it is more abundant, that is the cheapest one. So, argon is the more cheaper noble gas which can be used here.
Yes, sir.
Now, helium exists. I'll just add one extra point here as well. Right. Helium, okay, exists in three isotopic forms. Exist in three isotopic forms. Isotopic forms that includes helium-3, helium-4, and helium-6. These are all the isotopic forms we have. Right?
Helium 346.
Yeah. And see, except radon, other noble gases are found, in atmosphere. So radon is mainly found due to the radioactive decay. Okay, so this is how the decay would happen by which radon is formed. Clear? Helium
Right.
and neon are found in radioactive minerals like pitchblende, monazite, and cleveland. They are all found
Okay.
in this. Clear?
Yes, sir.
Yes. Next, by volume, if you compare, atomic size wise, this is the case. And uh, if you compare the volumes present in atmosphere, correct? In atmosphere, volume wise, if you compare, which one will have more volume occupied or that shows its abundance also. So
Hmm.
argon, neon, helium, krypton, and xenon.
Xenon.
Okay,
Right.
clear. And
Yes,
if you
sir.
compare by mass, which has most mass present in the atmosphere is argon, neon, krypton, xenon, and helium.
Right.
Okay, right. Ionization energy wise, if you notice, it will decrease down the group. Okay, this is the ionization energy
Right.
part of it. Electron gain enthalpy is positive for all of them. Okay, wherein neon will be greater, then argon and krypton will be almost the same, then xenon, radon, and last comes helium. Okay,
Okay.
so remember how the electron gain enthalpies, but all of them are positive values. That is important to know.
Yes, sir.
Clear? Right.
Yes, sir.
And next, melting point and boiling point, it increases down the group. Okay. Ease of liquefaction also, solubility also, it increases down the group. Correct? From
Right.
helium to xenon. And ease of liquefaction goes helium to xenon in the same way.
Yes,
Okay.
sir.
Adsorption of gases also in the same way. Density same way. Diffusion same way. Sorry, diffusion decreases. I meant to say helium to xenon, it decreases. Okay. Thermal conductivity will also decrease. I'm not sure if at all I've written that. I'll just put that wording. So, okay.
Hmm.
So you can see thermal thermal conductivity decreases decreases from uh, from helium to xenon. Correct.
Yes, sir.
Next important term is clathrates. Clathrates are the compounds where they are chemical compounds containing gases within the crystal cavity, and these are cage-like structures. Gases are held to the
Clathrates.
crystal by weak van der Waals force of attraction. For example, ice.
Okay.
Ice can be act as a clathrates. Within the ice, we can have xenon and radon gases getting absorbed. Okay, so they have
Okay.
been stored there. Yeah, so it is because of the ice having a cage-like structure, it can hold on to the heavier gases. Yeah.
Right.
Obviously, helium and argon are too small to be hold. They can easily diffuse out of that. Okay, because of its high
Right.
polarizability. Okay, beta. Sorry, I mean lesser
Yes, sir.
polarizability. So xenon will have more than krypton than argon. This is the stability of clathrates. Okay.
Hmm.
Clathrates in quinol are formed when aqueous solution of quinol is crystallized at high pressure. That's how we will store it. So you can see argon in a ice form will have, at least for every argon, there are six water molecules, krypton and xenon.
Right.
They all are the hydrates of water. Okay.
Hmm.
Stability of clathrates will also be based on the size. Bigger the size, more is the stability. Then,
Right. Yes, sir.
right, next. If you compare the chemical properties now, most of the noble gases are least reactive. One, because of their stable configuration. Second, they have extremely high ionization as well as high positive electron gain enthalpy. So none of them is helping it to make any reactions easily with other groups, okay, other elements.
Hmm.
Next, these elements react with more reactive substances under certain conditions. Hence, they are called noble gases. See, Niels Bartlett prepared the first xenon compound based on similarities on the ionization of O2 and Xc. Basically, O2's ionization energy is around 1175 kilojoules per mole. Okay. But
Right.
xenon, if it loses electron, that is also around 1170 kilojoules per mole. You can see the values are pretty close. And he found that there is a compound that exists, complex that exists as O2 plus and PtF6 minus. Okay. This is
Hmm.
a compound that has been identified. So if this exists, then he realized if this exists, probably if I react with xenon in a similar conditions, you should also get some complex. And he saw that PtF6, which is a colorless solution, as soon as you add xenon, it will become a colored complex, yellow, orange. So then he realized that xenon can also make some products. Xenon can also make some reactions with complexes or maybe helium or sorry, with oxygen or fluorine. Got it?
Yes, sir.
Does it mean only krypton makes products? Sorry, xenon makes products? No, even krypton makes products. Krypton KrF2, KrF4. These can also exist.
Okay.
Clear, beta? Right.
Yes, sir.
Now let's see the compounds of xenon. So if it comes to X2, when you react with F2, and considering xenon is in excess, or at least 2 is to 1 mole, this is minimum. Then at around 673 kelvins and 1 bar, it will form XeF2. XeF2 will be in a solid state. Got it?
Hmm.
Next. Its melting point for this is around 100 and, 402, 402 kelvins. Got it?
Right.
Next. As a reactions, if you notice, we have further, I mean, these reactions are already there, but anyways, I'll write it here just to practice this one more time. That is, if you take 2 moles of XeF2 and you hydrolyze that with H2O, that means you are adding
Hmm.
it to water, then you will get 2 moles of xenon, right, which is gas, and you will get 4 moles of HF aqueous plus O2 gas. Done,
Hmm.
beta. And similarly, XeF2, when you react with PF5, it will become XeF plus and PF6 minus. These are the complex can form. Done.
Hmm.
Now, next one, XeF2, when you react it around 600 kelvins and 7 bar pressure, the ratio should be around 1:5, correct? Then it will form XeF4. This is also a solid form. Its melting point is around 390 kelvins. Okay,
Right.
lesser than that XeF2. Okay, now if you see what are the reactions this can make it, see, this can make reactions like this. XeF4, clear, with
Hmm.
O2F2, that can, sorry, XeF4, when you react with water plus 4H2O, got it? 4 or,
Right.
no, no, 12 H2O. So we'll have 12 moles to be used. 12 moles of H2O. This will form 4 moles of Xe, which means I should take 6 here, 6 moles of XeF4. And
Yes,
that
sir.
plus 2 moles of XeO3. 2 moles of XeO3 plus 24 HF plus 3 moles of O2. Correct? Have you
Hmm.
noticed that xenon got, uh, I mean, it is at +4 oxidation state. It has becoming 0 and +6. So what has happened to xenon? Xenon got disproportionated in this case. Clear?
Right.
Right. Next. Uh, the next reaction for Xe is keeping 1:20 ratio at around 300 degrees Celsius and 60 to 70 bar pressure. Then you can get XeF6 beta. Got
Hmm.
it? XeF6. The other way of preparing that, see, this is one way. The other way of preparing that is you take XeF4, and then react with O2F2. And
Right.
this would also give us XeF6 solid. This is also a solid form. Got it? Plus
Hmm.
O2. This is another way of preparing. Here,
Yeah.
just like how I wrote the reaction with PF5, similar reactions can happen here as well. That is
Hmm.
XeF4 plus SbF5. That will also give you something similar, XeF3 plus and SbF6 minus. This is the type of complex that can be formed. Clear?
Right.
And here, if you compare the melting point of XeF6, this is around 322.6 kelvins. Okay. And just like how we have seen some reactions here also, if at all I put those reactions, what is the type of reaction I'll get? See, XeF6, when you try to hydrolyze it, correct? XeF6, when you try to hydrolyze this, it will happen in
Right.
multiple steps. Okay, so I'm writing all 3 moles at a time because again, I'll show you these reactions. So this will become XeO3 and to 6 moles of HF. This is the final
Hmm.
reaction that will take place. Okay, and similar
Yes,
to
sir.
the earlier reaction here also, XeF6, when you react with MF, that will give us XeF5 plus, XeF5 plus, and XeF7 minus, XeF7 minus, and M plus. Here, M has to be metals like sodium, potassium, rubidium, cesium.
Hmm.
These are the ones. Then this is the type of reaction that will happen. Okay. So I want you
Yes,
to
sir.
check it out, this ABC reactions thoroughly, beta, because they are all very similar kind. You know what type of important reactions they will do. Okay. Just check out for a
Yes.
minute. higher Xe fluorides can also be prepared by lower Xe fluorides, like I said. This is the reaction I already given you. Now, what are the properties? See, properties wise, if you notice, okay, all xenon
Hmm.
fluorides are solids and sublime very easily. Melting point, I showed you that this is the melting point order, correct?
Hmm.
And next, covalent character increases as you go down, and delta H of formation value increases as you go down towards this side. Clear, beta?
Right.
Now, comparing their oxidizing ability, XeF6 is the powerful fluoridating agent and also powerful oxidizing agent. XeF6, then XeF4, and
Right.
XeF4. Now, notice with water. With water, XeF2 makes a redox reaction. This makes a disproportionation redox, and this makes a non-redox. XeF2
Right.
is a slow hydrolysis. F4 and F6 are rapid hydrolysis. Okay, you see that
Right.
XeF2 plus H2O with slow redox reaction will make you Xe plus O2 plus HF,
Hmm.
and XeF2 plus NaOH, that will make a rapid redox to get Xe, O2 and NaF. Okay,
Right.
and this I told you, if you take 6 moles, first you will get, I wrote it for 12 moles, you can write it for 6 moles, correct? So you will get this into disproportionate of Xe, XeO3 and 12HF. Got it? Now,
Right.
this is the typical mechanism. XeF4 first get oxidized into XeO and XeO4, and XeO will convert into Xe plus half O2, and XeO4 will get disproportionated to decomposed to XeO3 and half O2. Now that on adding, you will
Okay.
get you this one. Okay?
ठीक है हाँ.
And 6. Next, XeF6, when you add it to water, depending upon, like I said, 1 mole. If I take 1 mole, you will get this one. If you take the second mole, you'll get XeO2F2. And the third mole, you will
Right.
get XeO3 and S6 moles of HF. Okay, beta?
Hmm.
Right. So XeO3 is alkaline in nature and it forms xenates. What is xenate means? See, XeO3, when you react with OH minus, it can accept the pair of electrons and converts itself into HXeO4 minus, which appears like a seesaw structure. Clear? And
Okay.
HXeO4 minus here. See, here it is
Right.
like this now, beta. Xe double bond O, double bond O. One is with OH, the other one is with O minus, like this. This is the seesaw form. Okay.
Right.
Now, if I keep this xenate for a long standing, it will start disproportionating. And in the basic medium, as it disproportionate, it becomes XeO2, and that will convert into perxenate. Perxenate is an octahedral structure with sp3, sp3d, sp3d2 hybridization. Got it?
Right.
So sometimes this sequence of reaction is been asked how the Xe O3 in basic medium behaves. In basic medium, this is what you'll get, and perxenate is formed here.
Hmm.
Clear, beta?
Yes, sir.
Next, alkaline hydrolysis. That means XeF6, when you react with OH minus, it will become XeO3, 6F, and 3 moles of H2O. But this XeO3 is the one which on basic will become the xenate, and that will convert into perxenate form. Clear?
Perxenate.
This one, perxenate form. Okay.
Hmm.
Now, so notice barium perxenate, when you react with concentrated H2SO4, makes a precipitate of barium sulfate
Barium
and
sulfate.
XeO4. XeO4 is anhydrate of perxenic acid. This is the anhydrate of perxenic acid. That means when you add water to it, you'll get perxenic acid.
Okay. Okay.
Clear?
Yeah.
Right. And XeF4 is highly explosive.
Okay.
Highly
XeF4 or
explosive.
XeO4? XeO4.
XeO4.
ठीक है. हाँ, ठीक है.
XeO4 beta. Okay.
Yes, sir.
Add. See, if you react it with silica, XeF4 is more reactive and it reacts with silica easily at room temperature. And when it reacts, it will form XeoF4 and SiF4. Okay.
Right.
And it depends on how many moles you are using. First mole will give this one, second mole will give this one, and last mole will give this one. So if I have to write the overall reaction, this is what you will write. So you can write it as XeO2 F2 plus SiO2 of 3 moles will convert into XeO3 plus SiF4. Clear, beta?
Yes, sir.
Okay. So that means it is like, sorry, this is XeF6. XeF6. So that means if I take this as 2 moles and 3 moles, so how many moles you'll get? You'll get 2 moles here and 3 moles here. Done?
Right.
Next. Oxidation properties. Xe, when you react with any one of them, it will easily form HF and Xe will get reduced. HCl will also get oxidized. Ki will also get oxidized. NH3 will also get oxidized to N2. Okay, so that means you can notice that all XeF2, XeF6, and XeF4, they are all very strong oxidizing agents. Clear?
Right.
Next. In aqueous solution, they can oxidize chromium plus 3 to Cr plus 6, cerium to plus 4, silver to plus 2, and BrO3 minus to BrO4 minus.
Hmm.
Okay. This is their ability. Next. They act like fluorinating agents. That means if you take any Xe or XeF4, if you react with sulfur, mercury, or platinum compounds, they will fluorinate
Right.
them and reduce themselves. And
Right.
likewise, if I take XeF2, react with NO or NO2, Xe will get reduced and NO or NO2 will convert into NOF and NO2F formation. Okay.
Right.
And see, NO2 and XeF2 will convert into 2 moles of NO2F. That's how it will happen. Okay.
Right.
Now, with fluoride acceptors, okay, that means they
Right.
are accepting the fluorides and converting them into an complex form. This is what we have noticed: XeF2 with arsenic, XeF2 with any metal with F5, that will convert into F6. Okay. In
Right.
fact, this is XeF2, but that XeF2 will again connect that with XeF plus. This is XeF plus, right?
Right.
XeF plus, and this will hold a strong bond. That's why it is being shown it this way.
Hmm.
Okay. And see, XeF2 plus 2 moles of SbF6 can also be explained this way because 1 mole of SbF6, right? XeF6 and 1 mole of SbF5. This is with minus and this is with SbF5. That two together can also have a bond like this. So they can also exhibit as Sb2F11 minus.
Hmm.
And lastly, BF3, cobalt, phosphorus, and antimony, they all with XeF6 will also give you this fluorinating forms. Got it?
Right.
And XeF4 can be separated from this mixture by using fluorinating acceptors. For example, XeF6 will convert into F minus. Sorry, here I wrote it wrong. For 1 mole,
Hmm.
you will get this as F minus and K plus. Yeah. While
Hmm.
XeF2 will convert into NaXeF3. Right. So this way, this molecular form crystallize in a different
Got
boiling
it.
points.
Hmm.
Got it? So that's how we
Yes,
can
sir.
separate them. Clear, beta?
Yes,
Right.
sir.
Now, last thing you need to learn is about how the structures look like, all of them. What is the hybridization? What is the steric number? What is their hybridization? How many lone pairs they have? And individually, how does they look like? So you can see XeO2F2. It looks like a seesaw. Okay. This is the seesaw form. This is seesaw. Clear? XeF4
Right.
tetrahedral. Okay. This is pyramidal.
Right.
Pyramidal. Okay. Xz
Right.
O4 6 minus. This is 6 minus here. Sorry. XZ04 only minus. Why did I wrote? Sorry. Only XZ04 with XZ04. No, this is not the correct one. Wrote it wrong. Okay. Next.
Hmm.
XZF6, you can see this is what we expect, but the actual structure is distorted octahedral. An
Right.
important one. XZF4 is square planar. XZF2 is linear structure.
Hmm.
Clear, beta? Right.
Yes, sir.
So these are a few important things that you need to know it from this topic. Clear? Of
Yes,
course, there
sir.
are some additional points. I will give you, I'll put it as a print on that, which is mainly
Hmm.
about uses of helium, mainly uses of helium, correct? And
Right.
how we can separate the gases, how helium, neon, krypton can be separated. Okay, although it is not
Right.
there in the syllabus, but it's just as a reading part, you can do it once.
Right.
Yeah, right.
Yes,
This is
sir.
how much you need to know it from this topic, beta. Don't need anything extra from this. Okay. Uh,
Yes, sir.
now, one second.